Long predicted by cosmological models of our universe, astronomers just detected a mid-size black hole for the first time, using an entirely new method, according to a new study published in the journal Nature Astronomy. The newly spotted mid-size black hole is the kind that many believe serves as food for early supermassive black holes, and thus the evolution of most galaxies, and is up to 55,000 times the mass of our Sun. Mid-size black holes could feed early supermassive black holes. Nearly every large galaxy houses an object of unimaginable proportions, a supermassive black hole. Each can grow to become up to billions of times more massive than our Sun, and serve as a crucial driving force at the heart of their host galaxies. However, the origin of these monstrous titans has baffled astronomers to this day. Some seem to have formed as early as 600 million years after the Big Bang, when the universe was only 4% of its current age. But this doesn't seem likely. There is simply not enough time to build such a massive black hole so early in the universe, said astronomer Łukasz Wysockowski of Warsaw University in an initial Quantum magazine report. Unless, he reasons, something feeds them. And the main course of supermassive black hole hopefuls might be intermediate mass black holes, giant ones whose mass falls between black holes, the mass of our Sun, and supermassive ones. Intermediate mass black holes could have a mass somewhere between 100 to 100,000 solar masses, and are believed to kickstart the growth of pulsing mores at the heart of many galaxies. The biggest problem is picking them out of the sky. Black holes don't emit anything, said astrophysicist Daniel Holtz of the University of Chicago to Quanta. So they're just really hard to find. Astronomers had a few candidate intermediate mass black holes in mind. In 2020, they caught what could be a 50,000 solar mass black hole swallowing a star with the Hubble Space Telescope, and then they found another that could have been a 20,000 solar mass black hole candidate, called HLX-1, possibly having a similar feast. However, in the present study, researchers claim they employed an entirely new method to locate a black hole up to 55,000 solar masses, ushering in an age of a new search strategy in modern astronomy that could unveil many more candidates soon. Double flash of gamma ray burst gave the mid-size black hole away. James Painter, a doctoral student at the University of Melbourne, led the new study. Back in 2018, his co-author and supervisor Rachel Webster suggested he analyze a data set of roughly 2,700 gamma ray bursts from NASA's Compton Gamma Ray Observatory, gathered between 1991 and 2000. Gamma ray bursts are colossal explosions of energy astronomers think happen when neutron stars merge, or when stars go supernova. Painter was seeking moments when two roughly identical gamma ray bursts appeared in a short sequence. Such a rare double flash could suggest a lensing effect enacted by an object lying between it and us, and it would have to be massive enough to bend the explosion's blinding light on its way to our planet. In other words, an intermediate mass black hole. Out of the entire massive dataset of 2,700 gamma ray bursts, the automated software Painter used highlighted only one event. A flash from a suspected gamma ray burst was seen by Compton in 1995, dated to have happened when the universe was roughly 3 billion years old. A second burst was seen to follow, just half a second later. From the data, the team found that an intermediate mass black hole sitting between us and the gamma ray burst was responsible for the anomaly, which also changed the angle of the flash from just off-center of the black hole. This means the flash's light followed two paths, one shorter than the other. The lens affects the path for two photons going around opposite ends, said Eric Thrain, co-author of the study and also an astrophysicist at Monash University, to Quanta. That's the delay time. However, the consensus about the origin of this double flash isn't unanimous. Astrophysicist Nathalie Webb of the Research Institute in Astrophysics and Planetology in France argues that Since we don't know the abundance of intermediate mass black holes exist in the universe, it seems unlikely that we chance upon a perfect alignment with one during a gamma ray burst. Some people predict an enormous amount, 1,000 per galaxy, in which case this sort of thing would be quite likely to happen. Webb said to Quanta, "If you didn't have such a large population, then yeah, it would be less likely." While there are other issues possibly casting doubt on the conclusions of the study, if it is an intermediate mass black hole, it might do more than provide evidence for the seeds needed to understand how supermassive black holes grow. More compelling is the mid-size black hole's ability to offer evidence for another universal mystery, dark matter, which scientists suspect compose 85% of the total cosmic mass. It's very difficult to produce such a black hole with regular matter, added Wizakowski to Quanta. You need to merge many stars, and there's not enough time in the early universe. Potentially a theoretical watershed for theoretical physics. And our grasp of how supermassive black holes get so big. This could become a major leap forward in our study of the universe. If you have any questions, comment below, and I'll see you in the next video.